Salaam alaikum. The confidence intervals of the population mean is the statistical way of generalizing information generated from one sample or one patient series to the whole population and calculating how confident we can be that the results obtained from the sample resembles the actual results of the whole population. Confidence intervals are based on the standard error of the population mean, and both the confidence intervals and the standard error relates to the population, the whole population, not just one sample. This is just one sample. This is a series of 182 patients with pleomorphic adenomas removed in one single center. The size of the tumors, the diameters are plotted here. The average size, the mean was 33 millimeters, and the standard deviation of this sample was 10 millimeters. But in other centers in the world, there may be another group of patients with larger tumors or with smaller tumors, depending on their setup. How can we generalize the information from this single sample to the whole population? We do this by estimating the standard error of the population mean. That is, we take the standard deviation of the sample and divide it by the square root of the number. The standard deviation here was 10 millimeters and the number was 182, and the square root, we obtain the square root of this number and divide the 10 millimeters with it, and the obtained standard error would be 0.7 millimeters something. So we know now that the real size of the pleomorphic adenomas elsewhere would fall into somewhere between 2 standard errors above and 2 standard errors below what we calculated as the mean of this sample. So we used information from one sample to gain insight by generalizing this to the whole population. This is again based on the concept of the area under the curve. 95% of the observations would be expected to fall within the limits of 2 standard deviations above and 2 standard deviations below a certain central observation or calculation or a mean in here, and only 5% of the observations are expected to be outside these limits. So the same concept is applied to the population, but using standard errors rather than standard deviation that we have used in the sample. So what does that actually mean? We have results of a single study in a single center about pleomorphic adenoma tumor size. And that study, out of several worldwide, had showed that the tumor size mean was 33 millimeters and the standard error was 0.76 millimeters. So 2 standard errors above and below the mean would give us the confidence intervals of the population mean. That is 33 millimeters plus or minus 1.5 millimeters. The confidence intervals are somewhere between 31.5 millimeters and 34.5 millimeters. Within these limits, within this 3 millimeters range, we would expect the population mean to be. And if this single series is repeated 20 times, then 19 times you will find that the mean of each of these samples would be within these limits, and only in 1 in every 20 different experiments or series the estimated mean would lie outside these confidence intervals. That's why the confidence intervals here are called 95% confidence intervals. So the confidence intervals are limits within which you would expect the true mean of the population to lie with a certain degree of certainty. The 3 millimeters between the 31.5 millimeters and 34.5 millimeters would contain the true mean of pleomorphic adenomas worldwide with a 95% degree of certainty. Now, if you want to be more certain, you could choose 99% certainty, but that would entail multiplying the standard error with 3 rather than 2, and that would also widen the confidence interval. So you would have a higher degree of certainty, but with a wider confidence intervals. The width of the confidence intervals are related to the accuracy of your estimation. And if you want to narrow the confidence intervals as much as possible, you would need to increase the size of the sample. Remember that the standard errors are calculated by dividing the standard deviation by the square root of the number of the sample. So the higher the number of the sample, the smaller the standard error and the confidence intervals will be. Confidence intervals may be used to compare different groups. For example, you could compare the rate of recurrences of pleomorphic adenomas in 4 different types of operations with their confidence intervals in there. And it's clear that this group is much less recurrence rate than the others, and the confidence intervals are not overlapping. Confidence intervals of these two groups have considerable overlap. By this, we come to the end of this presentation on the confidence intervals of the population mean. Assalamu alaikum.